live, our second one, so we're quite excited. I'm Philippa Dean, publisher of the magazine Railways Africa, and the host of today's live event. Today's topic is track condition monitoring, the implications of not monitoring your railway infrastructure. For this event, I'm joined by Matthew Davison, who is a director at Eurovin, Matthias Matteson, who is the CEO of Latronics, Eric Bergman, the founder. Is it EBER Dynamics or EBER Dynamics? Eric?
EBER Dynamics.
EBER Dynamics. Thank you so much for joining us today. Bjorn Scatz and Lars, who is also from Eurovin, a railway consultant. Good morning, gentlemen, and thank you so much for joining us. To our audience, should you have any questions, you can use the Q&A panel in Zoom, or obviously the chat panel on the platform that you are following on. Our moderator will ensure that I get them. We'll probably only do Q&A right at the end and not in between the presentations. So getting on with it, one of the key aspects of a safe and reliable railway operation is obviously well-maintained track infrastructure. In the context of Africa, where we have older track mixed with new track, we are sometimes constrained by underinvestment, available budget, really to maximize the true potential that condition-based monitoring specifically for track infrastructure can offer. Essentially, overlooking this aspect for whatever reason leads to implications of interruptions to services which ultimately cost money and damage to rolling stock and infrastructure, and in the worst case scenario, the loss of life. This all costs a lot more than having at your fingertips the current state of your track and the ability to be warned or informed of any changes in track, and thus preventing derailments and unforeseen operational issues. The true value, of course, lies in the ability to actually save money through efficiency, and that comes from knowing when to do what. And I guess the real buzzword, guys, is predictive. With the advent of technology and big data, we have the opportunity to monitor track conditions, not just occasionally, but continuously. The advancement of technology has also streamlined how this is done, from specialized vehicles through to portable equipment that can be placed directly onto an operator's rolling stock, which then provides the flexibility both in services and commercial viability. Hence today, we're going to talk about how this can be achieved, and I now hand over to Matthew from Eurovin.
Thanks, Philippa. That's a very good introduction. What I'd like to do is just walk through some introductory slides, just to introduce the topic. Hopefully my screen has been shared. Okay, so maybe just to start with some introductions about who we are on this call today from Latronics and Eurovin. Latronics is a Swedish company, very much engineering-led, and has been focused for the past 30 years on optical measurement systems. And for the past 10 years, they've been working in the railway sphere, utilising their expertise on optical measurement systems for the benefit of the railways. And that's really been focused on two main areas. One is the topic for discussion today, which is track and track geometry, so track condition monitoring. And the second is expertise and systems in catenary measurement. They've got a long history, particularly in the Nordic region, and are the leading supplier of such measurement systems to Swedish, Norwegian national railways, but they also have experience of working in other countries in Europe, like Denmark, Germany. As Philippa introduced, I'm a director and a founder of Eurovin. We're a railway consultancy. We operate globally, and we provide a broad range of services around consultancy, sponsorship, funding, projects, and we also act for some select clients as distributors. And indeed, we are the distributor for Latronics laser systems. So that was just a short introduction about who we are on the call today. And really what we want to talk about is some of the railway challenges that we see. And this is an interesting discussion topic, and particularly around track. Railways across the road have a challenge with track, and that is, how do you actually detect track faults? Yes, there's many human processes that railways use, whether that's capturing reports of rough rides from drivers, or manual inspection through walking the line. But humans are fallible, and it's not always possible to detect track faults. Similarly, track faults are often manifestations of deteriorations over time. And again, it's very difficult to detect track deteriorations over time with human-driven processes. You really need data. Similarly, if you see a track fault with the human eye, it's very difficult to assess its severity. And indeed, it's thereby very difficult to systematically prioritize remedial works on where they're most needed. And why is this all important? Well, I mean, track faults are a major cause of derailments. And derailments impact safety, they impact service, they impact financial performance, both in terms of lost operation, in terms of cleanup, and ultimately they impact the reputation of railway and railway operators. And against all of that, we understand track maintenance budgets are limited. So how can we effectively and affordably provide accurate, reliable track detection? And I think that's a challenge that railways across the globe have. So from our perspective, when we're thinking about these challenges, we understand that there needs to be a solution to detect track faults and to detect if there's any track deterioration over time, and to automatically generate alarms. That means that when we identify a serious fault, the railways can immediately impose temporary speed restrictions to enhance safety until those track faults are investigated and, if needed, remedied. It also means that, if we have data, we can actually understand the severity of fault, and therefore we can target track maintenance budgets on repairs where they're most needed. We're maximising the value of every pound or every pound, dollar spent on track maintenance. And finally, with the tools that are available today, if we make a track repair, we need to immediately validate if the repair has been done correctly and if the problem has been rectified. And again, with modern systems, we can do that, and that can be done on the fly, on the go, by the repair teams in the field to validate the quality of repair work that's done. So for 10 years, Latronics have been delivering the allot's track geometry system, and that's been keeping railways safe and efficient by monitoring track quality. And what do we monitor? So track geometry measurements actually laid down in a set of European standards, and we monitor in accordance with those European standards. And we're monitoring horizontal rail alignment, vertical rail alignment, rail gauge, cant, twist, and indeed we can also detect broken rails through inertial components that are in the OWL's track geometry system. The systems themselves are very easy to install. They don't have moving parts, they're very easy to maintain. In fact, there's almost no maintenance required, and they're actually built for any environmental and climatic condition. And indeed, the systems have been deployed on as permanent installations on locomotives, and they can be deployed on commercial locomotives that are running daily on track, or indeed they can be deployed as a portable solution on yellow works vehicles, so on excavators, for example. It's a very flexible, compact system. So one aspect is collecting the data. The second aspect is, what do we actually do with that data, and how do we actually turn it into meaningful information? So the OWL's track geometry system has a set of analysis software and is managed through an interface. And in that interface, we can set predefined track quality alarm limits. They can be set in accordance to standards or not, depending on the needs of the customer. And that data, it can be analysed and processed on the train and displayed to the train operator or the operator of the works vehicles, the team on site, or indeed monitored in the back end. And that can be done in real time. Data is transferred via GSM or, in fact, any other transfer interface that's suitable to a cloud storage solution. So the data is readily accessible for post-event processing. The system itself generates alarm reports in the case that an alarm is identified. And that can be displayed to the operators together with a map and GPS position, so it's very easy to identify precisely where the alarm was triggered on the track. And it's also possible to compare data sets. So if you remeasure the same track at a later date, you can very easily identify if there's been any change to the track data. And obviously that's particularly important if you're doing remedial works. So, as I mentioned before, the OWL's track geometry system, it can be deployed as a permanent installation on a measurement train, or indeed on a commercial locomotive. There's a mobile solution available for locomotives and works vehicles. It can be acquired as a service with periodic scheduled monitoring. Or indeed, it can be acquired as a one-off measurement service. Ultimately, our philosophy is to empower the customer, basically to put the customer to put you in control of your data. So maybe just to wrap up, railways are blighted by derailments, and research has shown that 15% of derailments are caused by broken rails, and a further 15% are caused by track geometry issues, including buckled track. Knowing this, and knowing the cost of derailments in terms of safety, in terms of reputation, in terms of financial impact, I guess the challenge for railways is, can railways afford not to invest in continuous track geometry measurement? So thank you. And on that note, I think I'm going to hand over to Matthias, the CEO of Latronics. Thank you.
Thank you, Matthew. Matthias, you're still on mute.
Okay, thank you, Matthew,
There we go. Thank
for
you.
the presentation. I will highlight some more information about the system and our company. Just a moment.
Are you managing there?
As
always
always, troubles when it's live. So okay. I can't open the file right now. I can perhaps just talk then. So my name is Matthias Mattsson, and I am the CEO of Latronics AB. Really short about Latronics. We are a Swedish company that develops and manufactures non-contact measuring systems for railway applications, both optical with lasers and inertial with gyros and accelerometers. Latronics CTO, our technical director, Björn Skatt, is also attending this webinar. He is currently somewhere in Stockholm in a measuring vehicle. Hi, Björn. Besides from tracheometry measurement systems, we also manufacture measurement systems for overhead line geometry. That's height and stagger of contact wire or catenary, and also wear of the catenary. On rail, we have also systems measuring wear and rail profiles. So today's webinar is about track condition monitoring. Latronics has ambitions to make track geometry measurements more accessible and affordable. Matthew mentioned some of the benefits of our system. I would like to highlight some more benefits and features. Not only measuring vehicles should be able to measure track quality according to standards. And by standards, I mean the European standards 138483 for work vehicles and 138482 for expensive track recording cars or measuring vehicles. Our systems can be mounted on a wide range of rail vehicles, such as commercial trains, locomotives, measurement vehicles, work vehicles such as tamping machines, grinders, or as on one picture I would have liked to show you an excavator. Maybe Matthew can share that screen with the excavator picture. The excavator on the picture has been prepared with a mounting bracket and two industrial connectors, one to 24 volts and one to a tachometer. It takes less than 2 minutes to mount or dismount the system. That's all it takes, so after 2 minutes it's ready to measure. The operator controls owls with a laptop or iPad with a wireless connection. And this is creating accessibility and affordability. Matthew already mentioned all measured track geometry parameters. For Cape Gauge, we divide owls into 2 units, one with sensors and one with other electronics. For standard gauge, all is built into the same unit. All processing of data is undertaken on train inside the system. And since all data are automatically transferred to cloud storage solution after completed measurements, both the operator on the train and people elsewhere with connection to the cloud storage solution have simultaneous access to measured data and can analyze measurements. With OWL's track geometry, you as a customer will have instant access and control of track geometry data, regardless of whether you are a measurement expert or operator. You can make decisions and act depending on the conditions of the track. For example, reduce train speed as an operator. So, I'm sorry I couldn't show you my slides. Now I will like to hand over to our much appreciated customer, Erik from company Eber Dynamics. Thank you.
Okay, then we'll see if my screen is working. Can you see anything?
I can see your screen. You just need to go into presentation mode. There we
Like
go.
that, perhaps?
Perfect. Perfect.
Okay.
Thank you very much, Erik. Over to you.
Yeah, I'm very glad to participate in this webinar. I like Africa a lot. I've been traveling there, visiting friends and some relatives. I think I've been in 8 or 9 countries. It's a great continent. I like it a lot. My background, professional background, is that I did some 15 years as a track engineer at the Swedish Transport Administration, where I worked mostly with measurements in the track. And the last 10 years, approximately, I've been doing development and consultancy in the company Eber Dynamics. So first, I would like to take the view from the Swedish Transport Administration, where I had a cooperation with Latronics within these questions. The Swedish Transport Administration order from another company that do the measurements, and they have 4 measurement cars measuring approximately 60,000 kilometers per year with those 4 cars. And for the main tracks, they measure about 6 times per year, and side tracks and so on 1 to 2 times per year. And so there's a lot of measurements. And Latronics has been a provider of their solution since 2009. all standard and limits that are used are based on European norms with some small modifications. And of course, the Swedish railways do most of their maintenance in track based on these measurements as input. And the goal for track geometry measurements is to keep the safety of the track, to find problems in track before there is a risk of derailment. That's the number one thing. And if you tighten in the limits a bit, you go into comfort, where you want to have a good comfort for travelers and for railway goods, freight. And of course, you want to do the measurements as well to do an efficient maintenance, not only go out on alert limits, but to build an efficient maintenance strategy. Still in Sweden, a large amount of the maintenance work is initiated by limit exceedances. But with digital data that you have in your own organization, you're able to do some trends and so forth as well, which I've exemplified on these different pictures. So on the top picture there, you see just one position in the track over some, I think this is 16, 17 years. And this position we passed about 50 to 60 times during these years. And we can clearly see that the deterioration is quite large at times. And then we see a very large improvement, a lower value. And then the deterioration starts again. And these jumps is, the biggest jump is actually when they renew the track. And after that, it's normal tamping. And if we take the upper figure and then color code it for 1 kilometer, you can see the lower picture, where blue is good track and yellow and red is bad track. And here is a great overview where we actually have the problems in the track and where they are recurrent, where you get them again and again. So with this at hand, you can make much better planning of what to do in the track. In Sweden, there are great thoughts of using this, but it's not used mandatory yet. As I said previously, most of the maintenance is still done just checking limit exceedances. A trend now for the Swedish rail is that with only 4 measurement cars, often they need to wait quite a long time for getting a measurement. And when they do maintenance work, they want to see directly, is the problem fixed or not? Can we increase the speed? Is there a danger yet? And even though you've been there with a maintenance machine, you cannot be fully sure that the crew did a good job. So that's has been a driving force for the development of Latronics to build a simple but yet accurate, affordable and flexible system. And it's now the last tests are done in Sweden right now, and it proves very well. The Swedish Rail Administration is really happy with what's going on. And now in my company, I work with the development of a measurement system called ETL, Eber Track Lab. And I'm doing that development in close cooperation with Latronics. And basically we have 4 track geometry systems fitted together, but on different distance from the loading wheels. And with that configuration, we are able to see how much the rail deflect by comparing the track geometry for the different positions. So by that we can present deflection and track stiffness for the customer here in Sweden and elsewhere in Europe. Okay, that was very short from my perspective on track geometry and what you can do with it. Thank you.
Thank you very much. So I think now that we go into the discussion session, anybody who has questions, you're more than welcome to ask. Please use the Q&A section if you're in Zoom, use the normal chat panels and whatever other online environment you're using. I think one of the key things, though, is that this is obviously an international solution. It has the advantages of being portable. And perhaps, Matthew, you can answer this question. How is this going to be applicable in the African context? So for our railways here in Africa, you know, sometimes we go, oh, international is great, but is it going to meet the standards that we need it to meet here in Africa?
Yeah, I mean, so absolutely. I mean, we've been discussing with several operators in Africa use of the system, and it's actually been in kind of two contexts. The first is to actually install a system permanently on one of the operator's commercial locomotives. So that way, they're in complete control of their track geometry data. And, you know, we intend to work alongside them to help them measure and configure and calibrate the system such that they can get meaningful information and make best use of their limited track maintenance budget, and drive all of those benefits that we see if you have a better handle on your track geometry. I mean, the other application that we see in Africa is deploying the system as a portable solution, whereby we would fly in, set the track geometry system up on one of their existing locomotives, and effectively lease the system for a limited period of time to complete a set of measurements. So that's the two applications that we see. I mean, the second application is to try and make the system as affordable, or the solution as affordable as possible for potential customers.
Thank you, Matthew. So I think, realistically speaking, what is the difference between having a specialized vehicle that does the track monitoring and you know, understanding all of that, versus having it portable? I mean, is there a significant difference in terms of the information that you get from having a specialized vehicle? And maybe Bjorn can answer this, considering I think he's sitting on a specialized vehicle at the moment, versus the portable system.
Well, a portable system is so much easier to get into the right place at the right time. I mean, this vehicle that I am in now, well, if you want to have a measurement with that one, you should probably order it like 9 months in advance so they can put it into the schedule. If you have it on a portable one, and you can mount it on a yellow vehicle, then it's so much easier. You can perhaps have several yellow vehicles with mounts, and you can have one sensor system, and you can take it where it is needed in the country at short notice, and you can. Well, I think that is the most effective way for some of the things that you want to do.
Thank you.
I mean, I would also add, Philippa, you know, a dedicated measurement train is a very significant investment for any railway to make.
Mm.
With these portable systems, it's a fraction of the investment cost. And at the end of the day, you get the same track quality or track geometry data in accordance with the same track geometry standards. Okay.
All right, so I've just been asked a question that says, what is the track quality index and what is your axle loading for the train traffic? Maybe one of you knows how to answer that, because I don't. Who wants to take that, guys?
I can try to answer from the Swedish perspective. We have track geometry systems on different vehicles, 2-axle vehicles where the axle weight is about, I think, 12, 13 tons, and one bogie vehicle where the axle load is 14 tons. And the excavators, we're trying it on now, it's about 6-7 tons of axle load. The European norm requires that we should have at least 5 tons of axle load to get a loaded measurement, because the track will not reveal itself if you measure without loading. So you need a loading, and that's in the European norm. As regards track quality index, there are different indexes. Most of them are based on calculating standard deviations of the different track geometry parameters and combine them in certain ways. We have a specific index for Sweden, and that's not in the European norm, but it's a formula based on the standard deviations. So I guess it's easy to calculate based on another formula if you want another track quality index.
All right, so I've just been asked, does your track geometry system also measure rail profiles? And that's obviously a big thing, the rail profiles, and I'm assuming it does. So raise your hand who's taking this one.
I think Matthias, why don't you take it?
Yes, thank you. Yes, it can measure rail profiles. This compact system measures inner rail profiles, and if you want to have the full rail profile, you have to add some more optical units from the outside. Often you only need the inner rail profiles. It also measures the wear and identifies the rail type. If you have another rail profile that we don't know about, then we can add it to the rail profile software. So yes, it does.
All right, so probably perfect for use here in Africa. It already sounds like it's less capital intensive than a specialized vehicle, and obviously this is with it being attached to the operator's rolling stock, it means that the track is being monitored all the time. What is the type of data that's coming through, and then how is that data interpreted? Is it done automatically? Do the alarm systems go off if something is wrong, or do you need a trained person to sit and look at all the data coming through?
I think Matthew has had a good slide where he showed the software. So it's you don't have to be an expert to find deviations, because you can set alarm limit. You don't even have to set alarm limits. You just choose speed class and the quality of the expected quality of the track. So, and that's also in accordance with standards. So, but you can for sure set your own limit values also. So.
And those standards, I mean, obviously are at present European standards, and you're saying that this can be changed and modified to ensure that it covers the operator standards or the operator specific parameters. Am I correct in my understanding?
Yes, it could be. Yeah.
I mean, I was just gonna add to what Matthias said about the question. I mean, the tool and the interface is extremely intuitive, and alarms are automatically generated, so you don't necessarily need to be sat monitoring and analyzing the data. You will be automatically notified of an alarm event if that's so desired.
Thank you, Matthew. Obviously, you know, this is highly sensitive instrumentation. And does it need to be calibrated to maintain its accreditation? I mean, is it that sensitive? You know, long term, how does, you know, do we need special tools to keep this going? You know, that's quite important here in Africa.
Should I take that? Yeah, well, it doesn't take a lot of calibration. It is calibrated in the factory. So we send it out and it arrives and it is normally okay. We try to, if it is fixed to the same position constantly, in Sweden at least, we go and we check it at least once a year. So having a local service company, that is something that Matthew will help us set up in Africa locally. Otherwise, it is very, very robust. It does not take much to keep it in very good shape.
All right, so yeah.
Yeah, sorry, I just wanted to add something. We do annual calibrations with our customers that has systems installed on measuring vehicles, and I think we almost never had any need to recalibrate. It's sometimes when you crash into something or you have some kind of accident with the system, then you have to check it. So, but that's recommended an annual calibration. So,
and then Matthew, you will obviously set up the supply chain to ensure that our customers in Africa can be supported, because that's a big thing with most technology, is that it's absolutely great and then there is not enough support to maintain.
Absolutely, Philippa. I mean, that's absolutely critical, ensuring that the support network is there so the technology can be leveraged. But that said, you know, even the calibration procedure is relatively simple, and with a very short training, I think actually customers in Africa would be self-sufficient in terms of actually being able to calibrate, if needed, the system.
Okay, well, I think that actually sounds like a great localization opportunity, and for some local content to be added to this system. I just want to remind everybody, those who are listening, that if you are watching via, I think it's Facebook or YouTube, you can put your questions in the chat comments, or in the comments section. Our moderator here is looking out for them. I do have a question here. It says, can the device and electronics measure maintainable time period, as in alert the operator or administrator in the system and signal room? Thank you. Who wants to take that?
I had
yeah.
Okay.
So I think when we talked about calibration, I think we mentioned also that we can provide the reference unit for doing the calibration by the customer. So it is pretty safe. But when it comes to the controlling and getting alarms from the system, you can, if you would like to have that in the signaling room, so it's close to the people watching the traffic, it's no problem. You can have it anywhere, and you can also have more than one user. You can have the operator driving the train can get alarms, or the work machine, but you can also have it in the signaling room or in any other places. For example, the people responsible for a special track can have his own terminal and get alarms. So it's completely flexible that way.
Okay, so it shows that it can be customized to what the operator is requiring.
Yes.
All right, so next question is, can it also measure vertical and lateral oscillations?
See.
Eric here. I can say a few things only about what sensors that are involved. You have an accelerometer in the system, and that one will measure oscillations within the vehicle you're measuring with. So for that vehicle, you can see oscillations. I don't think it's exported from the system today, but the data is there. But that oscillation is not valid for another vehicle. It's vehicle, only that vehicle that runs. I hope that answers the question.
If I understand, the oscillation is measured today to compensate when you do the measurement. So the measurement is going to be correct. So you compensate as the train is moving over the track. But it's also important then to mention that each and every measurement unit will be unique for each train, because it depends on how much wear and tear you have on your wheels. So if you have a completely new grinded wheel, it will have one performance. If you have an old wheel, it will have another performance. So that's why this is built into the system and compensate. So you do not have to be worried if you move the system from one train or from one working machine to another. It's taken care of. Thanks.
All right, next question is, can the track data gathered by the Latronics system be transferred to tamping machines?
We don't have that solution right now. We can look into that.
What do they really mean? I mean, transferred. It can of course be transferred, but
Yes.
Is the question if it would like to be integrated in something, some other system in the tamping machine? But
Yeah, you
have all the position data and everything, and that can be transferred to the tamping machine. So the tamping machine know exactly where to go and do the tamping. Because as I said before, you can have several terminals and watch the measurements. So if you have one machine doing measurements and the tamping machine coming behind, and they can of course see the exact position where they should go and temp.
And then you can, once you've done the tamping, you can just run the machine again, and you can see that it is now fixed, I'm assuming.
Yes.
Okay.
Yes, the system works measuring the track geometry parameters, but in regards to having a working interface to control how much to lift and so on, that we don't have. But for sure, you can drive, you can tamp, you can measure, and you can see that you have the correct track geometry.
All right, so the system itself will actually pinpoint exactly where you have an issue that needs to be fixed. So therefore, your tamping machine would know exactly where to go. And then, so the follow-on question from that was, so that the tamping machine can get the track parameters and work accordingly? That is a very technical question. Maybe Bjorn can answer that.
Yes, thanks. Well, yes, to have that automatical, to hand it over as a working order and automatically have the tamping machine take the order and work according to it, that will be an add-on. I'm really interested to develop that because, I mean, other customers will need the same thing. And there are not that many tamping machine vendors, so there will not be an infinite amount of output data types. So if a customer has a working system, and well, I'm really interested to work with that interface and make it usable, make it simple.
Okay, so I think we've answered that question. I will just get our moderator to check if they have anything to further follow on that. All right, so installation. I'm an operator and I've now bought this. How does one go about interfacing the system or installing the system on the locomotive? How do I get it to all work? What's required?
Maybe I can take that. It requires a specific measuring geometry. So you will receive drawings where to mount the system. It must be close to a wheel axle and in a specific geometry in regards to the rail. If you lack space, then we can make adjustments. And as I said in my presentation that didn't work with the pictures, PowerPoint, it depends on which kind of rail gauge you have, how we design the system. For normal rail gauge standard, everything is fitted into one unit. For example, Cape gauge, we divide it into 2 units. And then you can choose, perhaps you want to have the electronics inside the train, or perhaps you want to have it underneath the train. And we also have a unit we call ALS-COM, and that's the unit that contains Wi-Fi, connected to mobile network and GPS and so on. If you have a vehicle with lots of, you have to have a good signal. So perhaps you can mount that on the ceiling, for example, and then you have wireless connection to the operator. So that's the normal mounting procedure.
So that sounds like, pretty simple and not too complicated. How do I now get the measurements from the unit to the technicians? We've spoken about GSM. I mean, is that the only option? Are there other technologies involved?
Well, can I take that? If you want the information totally locally, if you want the information inside the measurement train, then you will have a Wi-Fi connection to a laptop or just an iPad. So you can check, you can both control, start and stop the measurement and see that everything works. And you can also analyze the measurement in place. You can print it out. You can export it to PDF really simply. You can export alarm report, and you can send it as mail, or you can of course have a local printer to print it out if it's a laptop. But the big advantage is that it is also shared online. We use Dropbox for this sharing today, but we can use any system to have it up in the cloud. So you can have the simple analyze tool installed on other computers. So the track engineer can directly view the measurement as long as you have some kind of GSM or 3G, 4G connection. It will be uploaded and you can check it somewhere else. We are also working on version to make it totally a web application. So you can surf into to a web page and you can do this online. So you don't have anything installed. And so there are those 3 ways to work with the data.
All right. So if I understand correctly, the menu for the tools have, different people can access that. So, you have the operator, or you have someone who's specifically dealing with maintenance and taking the decisions around that and prioritizing what work needs to be done when. And, so you have different levels of access where you have basically data that the whole organization can know where they stand.
Yes, that's correct.
And I think that assists in being, efficient with from an operator's perspective in terms of their resources and their planning. I mean, and because it's continuously taking place, the ability to track those changes or see the changes comes through quite, quickly without there being an accident. I just wanted to ask, when it comes to like washaways and things like that, I think we need to touch on that, because that is something that impacts, I'm sure it's the whole world's railway operations, but certainly here in Africa.
Yeah, no, I mean, we're well aware that washaways can be a problem. I mean, one of the benefits of continuously monitoring your track geometry is if there's by monitoring the geometry of the track, in some way you're also monitoring what's actually happening with the underlying track bed. So if there's changes in the underlying track bed, they will manifest themselves to changes in the track geometry. So by extension, if there is changes to the track bed, if it's starting to be washed away, those changes will be picked up and identified through the continuous data monitoring. Of course, it's not always possible to detect a catastrophic washaway event in an extreme weather situation. But certainly if there are changes to the underlying track bed over time caused by erosion, you would expect those to manifest in the track geometry, and therefore you would expect those to be detected.
Okay, so a question here is, since the system requires internet connectivity, and with some of our network running in remote locations where internet connections are not available, can the measuring unit continue measuring the track as they pass over that section and then update the database once internet connectivity has been attained?
Yes, that's correct. It doesn't need the internet connection for saving data continuously. It saves it locally, and then when measurement ends, then it sends it up to cloud storage for cloud storage. So it will continue to measure. And you can even save it on an USB memory if you'd like to save the memory, the data in that way. So.
Okay,
yes, there is always Wi-Fi connection. I'm sorry, there is always Wi-Fi connection. So there is the local controller tablet or a laptop that one always has the data, and the data is always saved locally onto a local hard drive. So whenever there is connectivity outward, it will be uploaded at the first moment that is possible.
Or failing that, you stick in a USB and you've got your data.
Yeah, well, in Sweden, Sweden is a very large country, and there is not always 3G connection, so it has to work also here, out in the woods and up in the mountains.
The next question is, how are power requirements of the portable system met?
Do you have that information, Björn? I think it's 10 ampere, 24 volts DC.
Yes, exactly. And there's a built-in battery, a built-in UPS. So if you have a temporary loss of power, that's not a problem. It will last about 20 minutes without power. So you can switch from one power system to another. If you have a generator locally and you want to switch to having power from the ground, it's not a problem to turn one off and connect to the next one. It will power through that gap.
And I suppose that comes down to the question of, what kind of interface is needed for the system. So maybe you can just go into a bit more detail around that.
Surely. Well, yes, 24 volts. If you have something other, we can provide the transformation to 24 volts, of course. And it doesn't have to be a very clean 24 volt, 10 amperes. We can use what you have. And we have it on the yellow vehicles in Sweden, and they don't have very nice power, so it will work. We also need to know we need to have a tachometer, something to know the traveled length of the system, so we can trigger the lasers at a constant pace. So we will either put a really nice tachometer on the wheelhouse if it's going to stay there for a long time, or if it's on a yellow vehicle, we have this really rugged system that you can just clamp onto one of the big wheels with indicators on the wheel. So when the wheel turns, we detect it with a simple sensor that you mount close to the wheel. And then there's this third system that you can use non-contact speed measurement with a Doppler radar. That is the simplest version. It's still under development. We will have to test it a little bit more, but it's going to be available. And that's what we are going to use if it's for a very short period on a lease, probably. Sorry. Well, those two connectors, those are the only ones. And then there's the Wi-Fi. We need the COM unit with a Wi-Fi antenna, so you can connect into it. Otherwise, we remote control it through TeamViewer, or we have a backup system also. So there can be several people connected into the measurement unit at the same time. I can be connected, and the the local user can be connected, and there can be a third one just watching over the shoulder. So we can simply use that for education and for service, for generally having really good uptime, so we can solve, if there is a problem, we can go in and solve it. And if anyone wants to go in and check the data locally, you can log in to TeamViewer to the local computer, and you can check it out instead of installing the program.
So Björn, what you're saying is it's only 3 cables: 1 cable to the communication unit on the roof, an antenna, 1 power supply, and 1 to the speed sensor, TECO or speed sensor. 3 cables.
Yes, 3 cables.
Thanks.
All right, so Isley, if such system is only used to run around and do spot tamping, it is extremely expensive. The focus should be on the total track maintenance methodology for a specific network. Thank you, Rikas. Anybody have comment for that?
Yeah, I can maybe comment. It's so that what we talked about before and what was presented is that you are tamping, there you have problems, and you can directly measure and put the track back in full speed without any speed restrictions. I mean, since these expensive measuring vehicles takes a long time to get there, or if you're doing manual inspections, you will have very poor documentation. Here you're going to have full documentation and can take the traffic back in speed directly after fixing it. There is also the alternative to have this same unit installed on the train, which passing the same track every day, so you can have a daily control of the track if you would like to. And that is very few can offer that. If you have a maintenance team, or if you have a special train going on the track, it can maybe take a year before you're going there, or a half a year. It can happen a lot of things. If you have a tendency for the washaways, you will never find that with the standard configuration with the measurement train, because it's going to come every half a year. But if you have it installed on your train, you can do both of it. So here you have the flexibility. You have the flexibility to measure directly during normal operation. You don't have to hinder the traffic with any special tools or trains. You just have it on your on the normal route. Or when the people going, maintenance people going out, they take the unit, bring the unit with them, put it on the excavator, for example. They fix the track, they measure after they are done the work, and then back in traffic. So you need both of these to be super efficient. If you would like to cover everything fast, having the track the traffic back in operation fast, you need it in fixed installation on a train doing daily traffic. If we would like to have the traffic back after maintenance, you need a mobile unit. So you need both of them if you would like to be super efficient.
Can I also cut in? Well, there is, if you want to measure if you want to keep the contour of the track, that is a lot of data. If you are only interested in the track geometry, that is well, the gauge and the height and the sideway, then that is about 1 megabyte per kilometer, and that is not a monstrous amount of data these days. So it is not a problem to upload or to keep all the data somewhere. But having a really well thought through plan about who gets to see the data, who gets, well, there needs to be a good plan about national who gets to see the data, but it is not a big challenge to keep the amount that is.
Thank you.
I was just going to add, Philippa. I was just going to
Sorry?
add, Philippa. I was just going to add to Rickus's question, because, yeah, I mean, as Bjorn said, for the track geometry measurement, yes, there isn't a huge volume of data, but we have to remember that the tool itself, it is in effect filtering the data into useful, meaningful information. So the user of the system isn't flooded with data, so much data and so much information that they can't actually take effective decisions. But I would also agree with Rickus that, you know, this is an enabling tool and an enabling technology, and it's only as effective as the overall track maintenance methodology and processes and the efficiency of the track maintenance operation in a customer. So in that sense, Rickus is right.
If there has been very little measuring before, then when you start out, you will have to have the alarm limits that are very coarse, so that you have a usable amount of alarms that you can work your way through. Then you can year by year set those alarm limits lower to increase the quality of the track. But,
and certainly with new customers, you know, our intention is to work alongside the customers, particularly at the beginning, to help the customers, if you will, calibrate the analytics of the system, so that the information that's being obtained from the system is useful and usable.
So I have a question here from Nati from Facebook. What's the measuring speed of the train for effective measuring? And I think because it's being put onto your rolling stock in normal operations, I don't necessarily think that there's a speed restriction to do the measuring, but I might be wrong.
No, that's exactly. It's not. It can measure in very high speeds. If you measure into slow speed, there are two standards: one for work vehicles and one for measuring vehicles, and it's a difference. It's differences in limit values regarding the track quality parameters, but to get to fulfill the standard as the measuring vehicles use, we need to drive at least 40 kilometers an hour. Below that speed, the system fulfills 138482, which is for work vehicles. And the lowest speed, I think, is around, you can correct me, Björn, I think it's around 10 kilometers an hour.
Yeah, I think so too. Eric, you have the correct figure.
Okay, so it's whatever speed you happen to be using at the time for your general operation.
Yes, for the optical system, there's no problem. You can drive 300 kilometers an hour or really slow. But the inertial components, they are based on moments, accelerometers and gyros, so they have to have at least a minimum speed to work correctly.
Yeah, so it will work from 10 kilometers an hour. So there will be a small gap when you start the measurement, when you accelerate, but it doesn't take very many meters to reach 10 kilometers an hour. And then it will cut. If you make a stop somewhere, there will be a small cut in some of the parameters. I mean, gauge is not a problem. Gauge is always measured and twist, but the height and the sideway will have some meters of gap. But normally you try to plan, so you start and you go to wherever you are supposed to make the stop.
So we've talking about we've spoken about speed. What about temperatures? I mean, I know in Africa we don't really get like the freezing cold temperatures you would get elsewhere in the world, but we do get really high temperatures. How does that have any impact?
Well, in Sweden, we have a specification that we have to measure from minus 30 degrees to plus 60 degrees. And if it's warmer than 60 degrees, then we can use active cooling, and that we don't need here, but perhaps in Africa, I guess. So it shouldn't be a problem.
And then how often does the system need to be maintained? I mean, we spoke about right in the beginning, calibration is done in the factory and maybe once a year, and that's the after service that Matthew's going to be dealing with. But is there anything else that one needs to take into consideration, the ongoing kind of optics of this kind of system?
Well, I can start. It depends on the installation. If you install the system on a measuring vehicle, then you perhaps want to have measure 20 hours a day or something. So you perhaps want to measure when it's raining, snowing, and everything. So we have a solution for we call it ingress protection system. So it depends on the application. If you want to measure and you have to have 100% availability, then you can build an environmental protection system around the owls. So that's a normal installation in measuring vehicles, because they don't want to lose data. But if you, for example, have a work vehicle and then you want to measure before or after doing maintenance on railway, the only thing you need to do is to wipe the windows clean. So it's not a problem. So it will be it's a scalable system, and everything has a modular design, so it's easy to choose the level of environmental protection.
Matthias, isn't it so that you also get indications if you have
Yes.
bad signals? So if you don't have ingress protection, you will get an alarm and you can wipe off the lenses, and that's it.
Yeah, that's correct. When it comes to inertial components, they don't need any maintenance at all. But if you have a dirty window, glass surfaces, then the system will alarm and say you have to clean the window. So.
But rain is not the problem normally. It is snow what can be.
No, yes, that's correct. Well, we also build the system for overhead line measurements, and then we have to protect against rain, because we can't have rain falling on the glass surfaces. So.
Thanks.
But where you place it, I think, Matthew, maybe you can bring up a slide of where the unit is placed. Let's take a locomotive, for example. Do you have a slide of that? I think that's,
Yes, just bear with me. Just,
I hope I don't crash your system now. It's quite nice not to have too many technical issues today. Nati's just from Facebook has just asked about on-site technical support, if that's available. I think, Nati, you may have missed an earlier part of our conversation. And I'm going to let Matthew will answer your question as soon as he's just brought up the slide with the locomotive.
Okay, let me bring up the slide with the locomotive. This is a slide Okay, not a commercial locomotive. I mean, it has been installed on commercial locomotives, but this is an installation, some pictures of an installation on a measurement train in Sweden.
But in principle, it's kind of under the locomotive. So, I mean, you're not necessarily going to get rain on it, are you? Can you get rain on it?
Well, I mean, you potentially can pick up spray, potentially,
Okay.
and moisture. But yes, no, so it's mounted, as Matthias had mentioned previously, the system is mounted underneath the vehicle. It needs to be mounted close to the loading point, so close to the axle, within maybe a meter of the axle, to ensure the accuracy of measurements. And as Matthias also mentioned, we do provide customized mounting brackets, so it can be fitted to different locomotive types. And, as again, Matthias mentioned, there's really no moving components in the system, no moving parts. So it's inherently very reliable, and really the only maintenance, if you don't take the full ingress protection packages required, is to wipe clean lenses if they get covered in dust or dirt to an extent where it's impeding the optical measurement. And if that happens, as Matthias said, the operator will be displayed an alarm, so they can take action to clean the lens.
All right, and then so Matthew, you can exit out of there, and then just to Rakesh, thank you for your question. We'll answer it now.
So maybe just to emphasise, because the question about on-site technical support.
Yes.
Yes. So I mean, on-site technical support will be available for the system.
And initial training and all of that, yeah?
And initial training, exactly. And we actually have a specific training package, and that's a combination of remote training through tools such as Zoom, and on-site training and initial setup of the system, and then ongoing support to help with the actual analytics and the data analysis. But actually, I mean, I think users will find there really won't be much need of a dedicated on-site technical support team, because the system is simple, doesn't really require any maintenance, and the actual graphical user interfaces and the use of the system in terms of actually using the data and the information provided, again, is extremely intuitive. So yes, we're available. There will be on-site technical support available, but actually we don't envisage a great need for that support.
Thank you, Matthew. Okay, so I have two questions here. The first is, can the system be provided as a service instead of selling the system? So instead of, I suppose, the operator buying the system, could they use it on a service basis? And then the okay, so answer that, and then we'll move to the next one.
Yes, so for standard gauge railways, today we do offer the system as a service. For Cape gauge railways, we don't have any customers for the systems as a service, so we would need to build a customized system to offer as a service. But in principle, yes, we can do. We would replicate the model that we're deploying on standard gauge railways for Cape gauge. So if there's a specific need and specific requirements, we're obviously very happy to engage and discuss, and we can tailor an offering accordingly.
All right, I'm going to do this one as my last question. Before we do the final wrap up, the last question is, it was stated that the system can detect broken rails. can you go into a bit more detail in terms of how this is achieved? And that'll be the last question. For those of you who have questions after we're done here, my email address is in the description, and you're more than welcome to email me and I will send it on to the team. So who's answering that last question?
I can maybe try to answer that. The inertial components in the unit will detect vibrations from broken rail. The system can not indicate, for example, cracks in the foot of the rail. No system can that today. There is no system such available. So if you have a crack that is open, then you can identify it thanks to the vibrations.
Anybody want to add to that?
I can perhaps add. Broken rail is a very wide concept. It's just as Lars-Ove said. Often cracks starts in the foot, and there's no system that can identify and find those kind of cracks. And the broken rail, it's very fast. It can happen after one train passage from a crack in the foot to a completely broken rail. So, but just as Lars-Ove said, accelerometers will find cracks, open cracks.
I think, Matthias, I'd also be correct in saying actually having your track with the correct track geometry, the design track geometry, can also help mitigate the risk of broken rails because you're not unnecessarily loading the rail beyond its design capability.
Yeah, that's the whole idea with the system. Proactive, maintaining your track instead of waiting for it to break. Because when it's broken, it's too late. So you have to be proactive and to reduce the number of breaks and the stress into the rail.
Okay.
Eric here, comment on broken rail as well. I'm not sure it's so easy to distinguish between a joint on a jointed track and a broken rail, or an insulated joint in a welded track from a broken rail. I think there need to be some more thinking on that, but I'm not sure.
You of course have to keep you have to know your track layout to detect, and when you have a new indication that you never have had before, it's a new indication and you can take actions. But of course, if you were running over a switch, for example, you know where you have a switch, and then it's of course a challenge to know if it's a crack, open crack, or if it's a switch which is giving it, of course. But you have on normal track suddenly a new indication that you haven't had before. Then you have a chance to look at it. But what we try to say is that you measure your track and try to be proactive to the changes in track, not deteriorating the strength of the track in advance. So what do you think, Eric? I mean, isn't it so that most of the cracks or broken rails is due to bad maintenance, or is it a perfect laid track still having same amount of cracks?
Well, I think the driving problem for broken rails are more rail wear perhaps than track geometry. So I think other parameters need to be into the analysis as well.
Okay.
Careful, we all get really academic here.
Yeah, really.
Yeah, but I think Lars-Ove has a good point to find, and also Erik, of course. If you drive and measure, and then you find it's hard to distinguish between perhaps a crack and a joint. But if you know where your joints are and you know your the track, you know your track, then if you have a new indication from the accelerometers, then it probably is some kind of damage.
And I think that comes back to the initial statement, which was you need to know what your track is. So there should be at least a first pass so that you know where everything is. And in theory, you as an operator would know where everything is. And then all the measurements that come out following that will then dictate or tell you where there are changes or potential problems. And with that in mind, I'm going to give each of you a moment to give your 2 cents worth before we close. And we'll start with you, Matthias.
Well, thank you first for the opportunity to take part in this webinar. It was very interesting, and we hope to be able to provide trachiometry measurements to Africa. So thank you.
Maybe I'll just say a few words. So yeah, thanks Philippa for organising, and thank you for the people who dialed in, listened to the debate and our presentations and the provided questions. Very much appreciated. Yeah, I mean, we're ready, working together with Latronics to answer any further questions or any further queries potential clients might have. We're very happy to demonstrate the capabilities of the system, and we think it has great utility for railways across the globe, but particularly railways in Africa. So thank you.
All right, so thank you very much to all of you and our panel for joining, for listening, for engaging. Again, presentations will be made available. Maybe just give us an hour to get that all ready. If you're not already subscribed to any of our channels, you can do so. And whether it's LinkedIn, Twitter, Facebook, or our weekly News Express, you will find this and a whole lot of other presentations as well. So from the Railways Africa team, I wish you a good day. Thank you.